Hello. Hi, everyone.
Hello.
Thank you for coming to AWPUG this September. It's September, it's AWPUG. So I'm Joe, this is Travis, this is Andy. We're going to have this event here. Did everybody get pizza and drinks and everything back there?
Yeah.
Yes, yes, yes. Okay, cool. All right, so a couple of things real quick. I wanted to make an announcement real quick. PyTexas, which is Python Texas conference, is coming up this weekend. Starts tomorrow, actually. Tomorrow's like tutorials.
Yeah.
In College Station. Is anybody here going? Okay, 3 of us are going. If anybody wants to go, I think there's still actually selling tickets, like $100 for the weekend. I'm driving down Saturday morning if anyone wants to carpool or caravan or something. So we can talk about it. So our program tonight will have Andy's gonna talk about real-time things. Somebody make sure to ask about real-time things. And then maybe afterwards, I don't know, is anybody here at Djangocon? Okay, like 1 or 2 people. If anybody wants to, like, I don't know, come up and share with the group something cool they learned or heard of Djangocon, would be pretty cool, but not necessary. We also will have some time to do lightning talks and stuff too, so that's if you're something you have a burning desire to talk to a captive room about, that would be the time for it. So tonight, our sponsor tonight is Umble. Very graciously provided us with the pizza and the beer and the water that we're all enjoying. So let's have a round of applause for Umble, and if Matt or somebody. So Matt's gonna come talk about Umble.
All right, thanks, Joe.
Hey everybody, who's heard of Umble? Oh, we got a few. Okay. Who's from Umble?
Alex.
Alex in the back is from Umble. Feel free to accost him if you want a job at Umble. So Umble is a customer data platform, and what that means is we help all of our clients collect and manage and view their customer data. So at any given time, we're handling thousands of events per second coming in from our clients' websites. We have a whole slew of salary workers that process that data. We have some Golang in our stack, which is basically a bitmap index that maps people to attributes and allows us to query across it. And as an engineering organization, it's a really fun place to work. Our office is at Seaholm in the old power plant. We just moved in there a couple months ago, and we're pretty excited about it. So yeah, definitely feel free to come up to me, come up to Alex, ask us about Umble, tell us about what you're doing. Question?
In a nutshell, the biggest thing you do, one thing.
We help our clients understand their customer data.
Okay.
Did that answer it? Is that?
Example.
We have a Django application. It's a web page that our clients can sign in and go to, and they can look at all of their customers segmented by many, many different things and see kind of aggregated demographic statistics about any given segment. So an example of that would be like the main page that comes up when you look at your customers, your property is all of their brand affinities. So it's just a list of what's the highest brand affinity that the most number of your customers like. And so usually it's maybe like Amazon.com, like 30% of your customers like Amazon. Of those 30%, 45% are male, 55% are female. The average age is whatever. And you can sort by any of those statistics and basically segment that, combine it with another segment, and see what that segment of customers looks like.
What sort of database do you use in the backend?
Well, that's a great question. We use several. We use Cassandra. We use MySQL for kind of smaller amounts of data, configuration data. We're using Redis for some of our indexes, and we have the bitmap index that I mentioned earlier that's written in Go is called Pelosa, and we've kind of built that in-house.
That's how you know you made it with 4 databases.
That's actually how you know you need to kick out a database, but that's a different story.
But why don't you stick to something like PostgreSQL or MongoDB?
So Postgres would be great, but we have a ton of writes. Our write load is extremely high, and Cassandra's really good at handling that. It's a much harder data modeling problem because you have to know the queries ahead of time, but it's really good at just accepting tons and tons of writes, which is why we chose that initially.
If you guys have more questions too, like afterwards.
Yeah, I think my time's up.
Anyway, thanks, man. Thank you. Okay. Well, without further ado, I'm going to turn it over to Andy. He's going to talk about that and how especially real time it is.
Okay. Thanks, Joe. So this was not the title of my talk. In fact, I'm not going to talk much about real-time things other than to explain what real-time is to a certain individual in the audience. But I am going to talk about web APIs, but I'm not really qualified to talk about web APIs because I've built exactly one in my life, and I will describe building that one. But I can talk about data science quite a bit. So how many data scientists are in the room? Okay, would y'all leave the room, please? That way no one will know that I'm wrong. All right, cool. So first, how did this title happen? I'm pretty sure it was beer plus Travis. Because real time is not exactly what I do. Real time is, according to Google, which I had to figure out, depending on who you talk to, they don't show the electrical engineering viewpoint, but it's actually happening which process occur at that time, or process within milliseconds, okay? So now, the nice thing about it is, like, I was actually talking to Travis Weisgood over beer and asking him how you get down to the real time of web APIs, which a blog tells me is 200 milliseconds. So in some sense that is real time, but having been someone who's actually worked on like big systems that like missile guidance and things like that, this is not real time. So let's get that out. But to achieve real time, I just kind of want to show how much data you can process in real time. So this is what the, here is 2 milliseconds. This is what Google thinks is real time. What missile guidance system thinks is real time is usually down here. And so this is nanoseconds. This is 1 nanosecond, 1 microsecond, and then this is tens of microseconds, and then milliseconds. And so how much data can we process in basically 4 of those or a whole lot of these guys? Not a whole lot. Python, just to give you a reference, Python, a function call starts about here, about 3 of these. So definitely not real time in Python just yet, but maybe we'll get there someday. So my real title was Steps from Data Science to API. Okay, so my kind of goal at this talk was to kind of talk about what a data science model is. How many people know what a data science model is? Okay, awesome. Then I was going to talk a little bit about like building a data science workflow. Like once you have a model, how do you build a workflow and a system that can crunch lots of data like someplace like Humble might do. And then I'm going to talk a lot more about how do you integrate an API. But really, the talk is going to be, tell me all the things I did wrong. Because my assumption is that a lot of you guys know how to program things for the web. Is that true? Who programs for the web? Okay, who hasn't raised their hand yet? All right, what do you do? Awesome. Okay, so that's basically what I want to talk about a little bit. We can talk about how to make things faster in real time later if we'd like, but I think the data science, once you see what data science models you kind of work with, it kind of sometimes won't, it's not going to be real time ever in this time, or this year, I guess. So first, let's start out with what is a data science model. So first off, like what is a model? Anyone have a good definition of a model? Jacob, you write a lot of papers about models.
An assumption of how we see the world.
An assumption on how we see the world, okay? So you have things like human models, math models, data models, which are not the same thing as data science models. which I'll make a point. Here's how I usually view it. A model is something where there is some theory that creates a box of computing something, and that box of computing something takes inputs and produces outputs. Okay. So a good example of this is human models. So I work at Fashion Metric. We do things for the retail apparel industry. So here's a case where you have women in clothing going into as inputs. You have Carl's mind going into the box and producing Chanel and other clothing lines, and out comes something I've never seen any real human actually wear, but it's there. That's one model. The first thing about models is they're not perfect, but there's some theory. Perhaps something that's a little bit closer to what people in this room are familiar with is a data model, where I take something like bits as an input and a schema, and I get out of that, from those bits in that schema, an actual data or some sort of idea of a data, pieces of data. So data science models are a little bit different. Effectively, you take a ton of data and then as an input to build the box that takes in a little bit of data and produces another piece of data. That's kind of my best definition of it. And you can kind of think of it this way, where this big part of the data is something like all the records that somebody hits on Netflix, or lots of data, something that's very massive. And you want to know one simple question, and you have some pieces of data about it. And then out of that, you get a lot of information, but it's just one very thin slice of that information. So data science really is about, let's not get people's minds in the idea, let's not get what people are writing, let's actually just go learn from the data to build models for more data that comes in to make predictions. Is that a decent enough definition? So yeah, I hear a data scientist shaking his head. Okay, good. Any questions about what data science model is? No. Awesome, I've confused everybody in the room. So let me kind of dial it back a little bit. How do you build that little box? I'm just going to break it down into 4 basic types, because that's how scikit-learn does it. There's definitely more ways to break it down. I think the first way is so it's 4 types: classification, regression, clustering, and dimensionality reduction. Different people add that last one differently, but they're all basically the same thing. So classification, a kind of question you might ask is is this a good book? So has this book, that's actually a really bad question, but you can say, is this a good book for a Democrat? Let's put it that way. So you want to label a book for a particular trait, or maybe is this picture a woman, or is this picture a child pornography, or is this credit card transaction a fraudulent credit card transaction? So a real world example is credit card models all the time are running and classifying whether or not, hey, this is a good thing or a fraud. So lots of little things, but it's basically around this idea that you have, is this A or B, a piece of labeled data. There's regression, which is trying to give you a value of something, like what is the temperature, a quantity? How many books is this person going to buy? How much money are you going to spend? Or a trading algorithm, what's the minimum price, and what's the right price for this stock, and things like that. Clustering is a nice one that you kind of fall back to when you have no idea what you're doing, is kind of usually how I put it. It's so which one of these things are not like the other, right? So often you're given a bunch of data you don't have labels to, you don't know much about it, you just know the bits that they kind of match up to and some dimensions of the data. And so you build recommendation systems with this very well. So when Netflix, they try to anonymize all their data, right, whenever they gave it out and gave it to people to actually see what is the best recommendation for this person that just has a whole bunch of different movies and that they've rated. And so what you a lot of people one way of doing that is to cluster up that data and see who's alike and which one of you alike and things like that. And then dimensionality reduction is probably the most crazy one up here, that if you haven't ever touched data science for. But effectively, you're asking what is normal. So I have a bunch of data, and usually it's too much data to manage. And so, for example, if I have 100 bits of data on a person, what are the normal person like, and which ones are often like the dimensions that matter to determine what this person is normal and things like that. So those are kind of the basic kind of models that you can build that all take data and produce a model that goes from data to different data. And there's a lot of algorithms involved. So scikit-learn is kind of the premier Python toolkit, and really the premier, I'd say the premier data science toolkit out there that's like does a wide, vast amount of different pieces. There's a lot of other things out there that are not Python, that are like Java or Go or things like that have pieces here and there or do one thing better. But one thing you can kind of see here is you ask questions like, do I have 50 models? Am I actually asking for a category for labeled data? Here, use this class of classification algorithms. And these are mostly, you get into those in a lot of linear algebra and mathematics once you get actually into the algorithm, which is a lot of fun. So definitely, if you're really interested in doing data science and want to do data modeling and ask questions like this, go check out scikit-learn. They have really great tutorials, and they can get you started. All right, so any questions about what data science is? Okay.
So,
yeah.
The scikit-learn, for example, does it tie well to like actual database models? Like, can you throw like a bunch of Django models that they say?
Okay, so it's data model is a schema that describes bits, right? Data science model is more answering these questions, right? So they're completely separate. What you would do with your data model is have it get your bits or really your labels or whatnot, and then you could feed that into your data model, but they're completely separate. They really have nothing to do with each other. Okay, any other questions?
I had a question about classification. So when you're trying to classify things, there are certain classifications which can be considered as fuzzy, right? So if you have a Boolean like an ARP or class.
Yeah, so there's lots and lots and lots of literature on how to do all sorts of different multi-classification type algorithms. And typically you can cut by one. I mean, this is like tons and tons of different methods of classifying label by label and everything like that. So you definitely go from the advantage of like, I want to predict A or B, but I really have A through E that I want to predict through, and you just kind of iterate through it in different algorithms and different things. So, but you are predicting a label at each point, so you can kind of break it down to decision trees and other things. So there's definitely a lot of ways to do it. All right. So the next time I want to talk about building like a data science system and like what are the kind of systems that go into it. I think, how many people know the Lambda architecture? One person, two people? Okay, cool. The Lambda architecture is really, it's kind of a thought bubble, really. And on the web, a lot of people write about it. Very few people actually implement the entire thing. Some people do. How many people worked at a place that implemented a Lambda architecture? One? Okay, cool. Did you like running that, or is it?
It's pretty complex.
Yeah, it gets pretty complex. But just as a thought bubble, the idea is that you have data coming in. So I have data coming in, for example, all the clicks on Netflix or all the log files from credit card fraud data, things like that. And you split that into two different layers. You have a speed layer and a batch layer. So the speed layer is where I just want to count things. I want to know like what happened very quickly. But you also want to, so you write to a queue typically, and then you write to some system that doesn't do very much computation, but then can hit your serving layer, which is where you can query. So if I want to know how many likes I have, I don't really have to do a lot of manipulation. All I have to do is hit a database and update a counter. So that data, I can do that like very quickly and update some database somewhere, okay? The top layer is your batch layer. So for example, if I want to, not only do I want to see what you like, but I want to see, how many people you like that also like a certain book, right? Or if how do I get a recommendation out of that same like? Well, that takes a little bit more time. And so this layer down here, you can get very fast. This layer up here usually provides some batch processing. So for example, a good example is the Google's word correction kind of algorithms, right? The Google word correction algorithms, you type in a query to Google, it goes through the speed layer and it keeps on adding all these queries you have. It also saves the store, and then whenever they want to update their index on what are commonly misspelled words, they run batch queries to like see which words are repeated after each other. Like 2 queries where the hamming distance is very small, so there's only like 2 or 3 characters difference, and so that's actually how Google runs their word correction, and so they then write to a query system. So another database. So one of those 4 databases we might have heard about, right? So the nice part of this is that why it's a Lambda is that no matter what you do up here, you can always replay your data from the speed layer because it goes to a queue and has a nice historic layer. And so you can always back up and fix your queries and fix your query engine. But at the end of the day, there's just 2 kinds of computing. I have data come in, I'm just going to do small statistics on it and get it into my database quickly, or I'm going to actually run one of these big models on it and kind of go back and forth there. Okay, so that's the Lambda architecture. This is how I think a lot of companies will run either this top part a lot or this bottom part, but very few companies actually run the whole thing. So you have to have kind of a big operation before you really need to run the whole thing. But it is kind of nice to kind of see what these things do. Underneath the hood, it all comes down to like an event-driven architecture, and any one of these workers, I usually have some pipe that has something coming in, and I'm running a bunch of event processes off of. So in the data science workflow, it really is kind of a data flow algorithm. In fact, if you go to like Google today, like they all talk about data flow as their architecture. Like, oh, don't use that Hadoop for your batch layer anymore. Just use this data flow event processing. Give you an example. One thing I've worked on in the past was web scraping for images of underage women being sold for prostitution. Okay, that's a different story, but basically we would take Scrapey, which is a Python scraper engine that would then fan out and go out and collect ads on the internet and grab images and different pieces of data from that. We'd throw it into a Kafka cluster. So Kafka is a log processing system written in Java, but it's okay. There's some things I've talked to in Python. So Kafka gives us basically topics. So if you come in and say, oh, this is in Georgia, this is in Texas, and you can actually rank different topics and run very simple queries on it based upon what you throw into it. And then we'd have a whole bunch of different models that would come back and say, oh, these images are similar, or I pulled out this phone number and it matches these other phone numbers, things like that. So we'd run a whole bunch of different machine learning models, and our query system we were using at the time was Elasticsearch. So Elasticsearch is basically just an index that's has a nice RESTful API that then Kibana and some other nice visualization systems hook up to. So that's a real world example. And this is really kind of more of a speed layer kind of mixed in because we're running quite a bit of models, but we didn't throw it into our queuing layer. Although if you hook up Kafka right, it'll dump to HDFS for you and things like that. So that's kind of an example of building out one of these systems. And so in my previous life, I built a lot of these systems. So that's kind of, so any questions about like how these data systems basically work? Yeah.
So is there some kind of real world example where you say that, hey, now I have to transition to this architecture, like this other architecture, or I can just keep doing one layer speed?
One layer speed path. So typically when you're running a big system like this, the idea that you never have to actually have multiple workers of these. Sure, there's lots of examples where you don't need multiple workers. Those typically don't run once you get to a certain level of data, you start to need to fan out in different ways. And I think that the nice real world example here is you could run this whole thing as a pipe, right? And not have Kafka at all in there. When you start, and so you could just have a scraper go to scikit-learn to go to a flat file if you want. And there's lots of people who start off that way. But as you know, if you're trying to crawl millions of web pages a day, it's not going to hit fast enough, especially trying to get all the models, different models cranked out. So one way you get that speed is by fanning out. So there's definitely real world examples of not ever touching this. So you don't need an actual big data system if you're running just a small classifier. Like when I bought a house, I actually went and classified all the ML listings, the database listings for houses, and like that took me like an hour. Okay, so there's definitely a lot of small data problems out there. So I guess there's so many, it's hard to like pick one. Okay, so that's basically how it. Any other questions? Cool. Who's gonna go implement Lambda architecture tomorrow? Awesome, one guy. All right. I usually give this talk and I say how to use Hadoop and all this other thing. I ask how many people use Hadoop, and I've never gotten anyone to actually use Hadoop.
You would not use Lambda architecture because it's just expensive?
Yeah, it's complex to run, so you got to run all these systems, right? So how many computers are you running? You got to run a database and an HDFS cluster, and so I think the average shop gets kind of hung too quick on those. I think just having to keep all that provenance and run so many systems. I don't know. Maybe you have some more.
That's exactly what I was saying.
Yeah.
Complex.
Yeah.
You have to have your DevOps team ends up growing quite a bit just to support the system.
Yeah, so I think that's true for a standard website, maybe some, although there's, like, I guess the thing is like, imagine if all your DevOps, the companies you worked at only worked on the backend cluster, and then you really kind of need to double them because there's not great standard tools. Hadoop's a 15-year-old, 16-year-old system that's kind of clunky and not great to use. And so finding DevOps people that actually can use those is kind of nasty. But they get paid well, so we'll make a lot of money with Lambda DevOps person. That's always, anyways. Does that answer your question?
It's complex.
Yeah. It just makes it more complex, and anytime you have if you really want to run data provenance and data, very few people actually have this problem that if they lose their data, that they lose their company. People who do definitely run something like this, right? Like Netflix and Google and places like that, they take data provenance very seriously, and they run things like a Lambda architecture or something like it. But I think very few people actually have that problem. Definitely not the porn industry. If you're in Silicon Valley, they apparently have no problem giving away their data. Okay, some people watch this show. All right, so how do you integrate an API? So I once said this at the last job I had. An API is just a function call coming from the web. How hard can it be? So now I got to learn. And this is where you guys get to tell me what I did wrong. So things a data scientist doesn't think about. So error reporting. Yeah, if there's an error in the data, we'll recompute it later, or we'll let it, we'll figure it out later. So getting actual error reporting working, not always working. Actually logging what queries you're making, database takes care of that. Monitoring how the thing works. If it stalls out, you come back the next day and fix it more or less. After all, the speed layer is basically automatic. Caching, authentication, dealing with users. Other people touching our system? No, that never happens. SSL, I hate SSL. How many people love SSL? Okay, man, I really hate SSL. Rate limiting, something that's as simple as rate limiting actually turns out to be more complex than I ever thought could be. And then web server configuration, I think the devil of DevOps. I think that was the one that I hated the most. The fact that it turns out to be an easy fix, but it takes so much time to figure out what the right settings for your server is. Did I miss anything about building an API up here? Anything that you put into your APIs? Is that like the whole thing? Yeah?
What does the message look like when it comes back?
Oh, for API?
Yeah, like that's sort of the primary thing that I would think about. It's just like,
For me, it's just a JSON, right? A JSON thing of data, right?
Right.
So a datum of JSON. So.
But what does that look like? Like that's what needs to be considered, right?
Yeah. Okay. So that one's I think fairly simple, right? Because I have a schema and some JSON, right? And if I'm really conscious about speed, I can use CBOR or some other gzip type thing. Yeah. So I can handle that. That's data. That's awesome. That's not. Back to Joe.
How pedantic do you want to be about REST?
About REST? Okay. Who actually implements all of REST, right? You actually have, what is it, put methods? Yeah?
Or fake commands.
Oh, see, there we go.
Something doesn't.
Huh?
You can just use something that doesn't for you.
You can, but then you have to expect that the web thing that the other person is using actually implements it correctly, which is why I think put is a bad idea. I'm sorry?
That's usually where it falls down.
Yeah. So I can tell. So I work with fashion people, so I can tell them what a get query is. Explaining what a put is. Oh yeah, you put your data in with me. Yeah. I just tell them send me your Excel file. It's okay. Another question, Mike? No. Documentation. Yeah. I'm a data scientist. I don't worry about that. It doesn't even go on the slide. I actually have a design. I am not kidding. I actually have a designer. I gave him a Sphinx doc. He copied and pasted it into InDesign and made a nice PDF and sent it to a fashion person. So that definitely something to think about.
Do you have access control, or is that part of
authentication? Yeah.
I was gonna ask that actually. Yeah, like grow all level access control.
Oh yeah, no, we don't. We're not like row column level into the database. We're running the model, right? We just want to run the model. So all you're going to get is the output of the model that you need. Right. Any other thing I forgot? Just hand up.
versioning?
Versioning?
Yeah.
That's a good. I didn't add that in here, and I don't know what people like. How many people version their API? Okay, how many people like versionless APIs? Nobody. Okay. So I actually went with a versionless API just because I don't want people yelling at me from the fashion industry, because I work with a lot of people who, like, if WebSphere breaks, they're upset. So maybe is that a bad choice? Bad choice?
But you're locked in forever then.
Yeah. I'm locked in taking an input string forever and interpreting that some way, right?
And an output format. I mean,
and an output format.
It's okay because your default one is version 1.
That's right.
And so your next one, you can just stick a PC line and it's fine, right?
I can cheat and add a version string into my, when you bring it in, you bring me a version string with it, and I can then interpret things differently. But no, that's versioning is one that actually there was a nice blog post that explained how to write an API, and someone who wrote the first version read that, and like now I disagree with everything he says, and one of the things he said is keep your versions separate from your code, or from your source control, but okay. So let me tell you a little bit about my story about going through building all these things. So first off, was it building the prototype? Yeah, I downloaded Miguel Greenberg's book, The Flask Web Development, because of my experience with Django, it's awesome. But I didn't want to have to argue with Travis Weisgood all the time about the right way to Django. So, but no, it's sexy, right? You have one function and you decorate it. That's pretty sexy. You don't have to think about all those things. The other thing we're thinking about is like, all right, obviously I like to draw block diagrams and do system ideas. So it's like, all right, microkernel architecture, like that's the way everybody does things. So you look at how these people do. So you have client requests, you hit an API gateway that then will hit all my different workers that then serve up queries, right? How hard can that be? So here's what our first system kind of looked like. And hopefully you guys can read, because I guess the font's a little small. But so basically we have AWS load balancer coming into multiple of these workers. We have EC2 instances that run a Docker gateway, because Docker was the thing to use. That runs, Nginx plus Gunnycorn or Gunicorn, however you pronounce it, with a Flask kind of endpoint that then hits actually my code, right, the API gateway. And then because we're going to scale it out, going to have a different scale out for the models, we're going to have another load balancer someday and a queue and things like that, and have the data models on another one of these containers. And then we kind of like strapped on all the other services, like AWS Elastic Cache for Redis and to just dump small little data. We had a lot of in RDS, we had a lot of our data models, so that big process we ran, we actually just threw it in an RDS to pull out the data model. And so then I could get the data model, the actual model, and then run the model whenever I got a query in. And then I have all sorts of little services on the side, like rollbar for errors, SendGrid for emails, because at some point we decided we were going to just send emails of the data we sent out, which turned out to be no one really wants that. Then we have like run scope for monitoring the thing, and then everything talks to paper trail. Okay, so that's our thing that just collects all our logs. It seemed like a good idea. Is there anyone who wants to take this and tell me what's wrong with it? Docker? Okay, Docker's wrong with it. That's actually on my list. Why is Docker wrong?
Probably your authentication and security among user access groups.
Yeah, no, I can still put in an authentication model. So if you come in, I give you a key to my API gateway, I can still check that key against Redis. But there is an authentication issue with Docker, and that has to do if you're using Docker Hub and you have secrets and other things like that, how do you handle those things? I actually don't have like a secrets, like a vault or something in here manage my secrets. So they got put in the Docker image. So, but that's.
Are you only running one container per instance?
Yeah.
I was going to say, you don't have enough containers up there.
Yeah. So that was definitely the first thing. I mean, we actually did run, this core would run like 4 or 5 of them. But it would be like one container. So you might as well replace that with an API, right? At that point. But Docker does give us some benefits that we can roll back to a previous Docker and things like that. Docker is just, I think the thing that killed Docker for me is just too damn slow to build. To build a Docker container takes forever. I'll tell you about it a little bit. I think the other thing that's wrong with this is all these fat arrows to databases. If I'm running a scalable API that's going to someday be real time, perhaps, I can't be hitting this many databases, right? Having 3 connections per query is terrible. Okay, so it's connection pools and things like that, but that's another really big problem we had with this database. The other problem is that our actual nodes are talking to things that are outside our network, like SendGrid and rollbar and paper trail and stuff like that. Although paper trail is a UDP thing, you don't have to worry about that too much.
How are you talking to Elasticache and RDS?
Because RDS handles all of our big data. Okay, so that's a good question. We shouldn't have been, because we read the book and we read the book and did it wrong. So that was a big problem. So the other thing, so coming in from the load balancer, we saw a huge hit. So the load balancer took care of SSL for us, but SSL was at least a half of our query time. And then we made 2 jumps to machines when we could have been on 1 machine, and we were hitting these 3 database connections. Really caused kind of problems for us. And I also read this nice blog post, service disoriented architecture, and then I remembered, oh yeah, service oriented architecture, that's the thing we used to make fun of, like back in 2004, and it's come back as microkernels. And so this is a good rant. The quote is you have a second computer once you know how to use the first one. So let's reduce the number of computers. But I always love this. The first rule of distributed system is don't distribute your system. And that's always a nice rule. So big problem, lots of redundancies, too many data dependencies on the database speed. So if our database slowed down, we slowed down. And then I think that the one thing that blog post made a lot is like compounded bugs. So if you have a bug across a socket, debugging that is very difficult. Whereas if you have a bug just in your monolith compute kernel, you can just fire up a debugger and figure it out really quickly. And so I think that's something we saw quite a bit, where the API gateway tells us something's wrong, and it's actually something way down deep in some data model somewhere. And our first setting of Djangocon was setting too slow, and we kind of played around with that a lot. And Docker, so I basically switched to Anaconda. So I used to work at Continuum Analytics, and had something to do with some of the Anaconda, so I believe in Anaconda. But Anaconda could manage their dependencies needs instead. Because I think most people use Docker because it makes it so devs don't have to talk to operations people ever again. And I think that what I've seen is that it leaves a lot on the table to be desired. But whatever. So our next kind of like iteration was, all right, so I already know how to use Kafka and log systems, so why don't I just talk to that thing? And it's a log system, because most of the data that comes down from my API gateway, I don't really need unless something gets screwed up. And I get so many queries that if 100 of them get screwed up, I'm down for 2 hours because of something, it's not that big a deal, because I'm just predicting data back and forth. So I'll throw it to a Kafka queue and make that a small one. We move Redis onto the actual node, so I might have a cache on the node for anything I hit. And that thing goes to Elasticache, so I can have a lot of different things talking to Elasticache and pulling data off of. And then I only have to build, so in Elasticache, this is a little weird, but actually, so the Redis will actually go through, the Redis instance, manager we have will actually, if something's not in the cache, it'll come back to RDS, but that's a rare event now. And so we only talk to RDS whenever we actually need to. And then the beauty of this also is if I want to build an interaction system for my users to see how much their nice graphs and how much things are being used, they only have to talk to this the portions of this RDS that we need. I think that's my wife texting me. All right. So this became a lot cleaner. You do have to manage Kafka now. So now I have to really add Java in there. But the other side of it is I don't have third-party systems that go down and cause my system go down. Oh, the other thing is I had beers with Travis and he told me just to use Varnish. I haven't actually added Varnish in here, so I don't know if that's the right place to add Varnish, but we'll figure it out. I hear people laughing. Am I wrong? Can I just add it there? Or
It's in front of Nginx.
In front of Nginx? Yeah. So it'll be in front of Nginx, and Nginx will go to Gunnycorn. All that sort of stuff. Cool. So that's how we integrate now is Kafka, which we're already playing around with, and our data query system can be shared between our data system and our APIs, although we do that back and forth. So is this better or worse? How many think this is better? A couple of people? How many people think it's worse? How many people are like totally lost and don't even want to raise their hand? Awesome. All right, there's got a lot of non-participators here.
So how many instances are you actually running? Like why do you need a load balancer when you've got one box?
Well, I don't have just one box because I have those dots there to mean more boxes. I'm running about 6 right now in my cluster. But I also like the load balancer because it's super cheap and it means that I don't have to worry about a lot of the DNS crap. It also it's one place that takes off my certs. So having that, like one place to check certs, and then it can fan out to my cluster. And so the load balancer, actually I started switching to a load balancer over some of our DNS tricks after we had to change something on the DNS and it took 2 hours to actually get updated. And we're like, can we be down for 2 hours? Who are we telling they can't buy clothes for 2 hours? So that's one. So I use the load balancer for redundancy and for making the speed layer. So, any other questions about that, Joe?
If ever you actually make this truly real time,
Mm-hmm.
And you want to use something like WebSockets or something to these calls.
Yeah, I'll never need WebSockets because I'm just sending you a JSON. Well, maybe I'll use a WebSocket at some point, and then I guess I'll have to keep connections alive to this thing somehow.
Yeah, and that's the load balancer will do that.
Yeah.
There's a way to hack it in there, but it's not specifically with the EC2.
Yeah, I mean, I guess the other side is since we work with a lot of fashion, right now we have a lot of small fashion clients, and they don't know anything about web stuff at all. So taking SSL off of their stuff is like, I'm too afraid of that. But yeah, I could see, if I was going to set this up for somebody who really needed to run like super fast things, I mean, what would you do? Is you check to see where your socket was at and put you over there like a filter that then figured out where your socket was going to, or how do you do that?
You can. I mean, you can make it kind of like a sticky thing where it now goes to the load balancer once with HTTP request that goes.
You just pass back the actual
to a direct server, or you can just make the load balancers just work at the like TCP level instead of HTTP level, and then there's a kind of way to do it that way too.
You might use SSL
Yeah.
there, so it's.
Well, I'm already going to have to lose SSL for like some of our bigger clients because they just. I think that the fastest I got SSL is 200 milliseconds. Does anybody have better numbers or using? Yeah. How do I make that?
That seems really slow.
Huh?
That seems really slow.
So I looked on the internet and like there's a lot of people who like say that's the like there's some blogs that say that's what they expect, but it does seem super slow.
You should be able to get to 50.
Should we get to 50? Okay.
You might have to go with metal instead of VM.
With what?
With bare metal.
Oh, bare metal. Yeah.
Yeah, backspace.
All right. Cool. Any other tips? Yes.
So what was slow about building your Docker container that turned you off the Docker?
There's a really great talk by a guy from Spotify, I think, who talks about this. But the Docker file, I don't know if it's I don't exactly know, like why. His viewpoint was the Docker file protocol is just slow, and they were much faster with makefiles and things like that. And so the way he described it was enough complexity. I'm like, I don't really need to worry about it because I can just use Anaconda and it's super fast. So I mean that was just one. Like so it took us, I think it took us 10 minutes for the Docker file to like even like start really. I think that's as fast as we could get a Docker file going up.
Gotcha. And that was on each like increment of like you change the code and you have to wait 10 minutes?
No, that was like my build system. Like when I want to like, because definitely there's probably better systems out there that when you just change a little bit of code only it takes off the image, but then you have to deal with the image cache problem. Like I have to have a large set of image caches somewhere and that adds some more complexity.
Gotcha.
I think those are the three biggest problems the guy from Spotify brought up is image caching. You get tons of images, you have to manage a cache of them somehow. You have to deal with authentications, like all the secrets, all your database logins, all like different pieces of your code that has passwords has to be baked in somehow. And it's kind of like some places solve that, but it's another complexity. Whereas if you just download a file from AWS or something, it's a lot easier. And then I think the third one was build times. So
that can all be handled by creating more containers. I know it seems like
I love this guy. Just create more containers. It'll solve the container problem.
But that's the problem with Docker is like the answer is always well you need another container for that.
Dijkstra would have loved you, man. All right, cool. Some things I learned along the way. The fastest response time I could get. So there's like Tech and Power Blog that does a lot of benchmarks. That's pretty cool. There's this WSGI web service benchmark from Funkload, I think, or whatever. But the one that we found that was like super fast that I don't know if anybody uses is this Mindheld. Does anybody use Mindheld? Has anybody ever used Mindheld? No? So Mindheld, by just changing the one line in my Djangocon worker, I went from 50 requests per second to 200. So that was really, I think in that one, I'm pretty sure that's basically limited by my database connections. So that was a nice kind of thing we found. We've been playing it a little bit. Oh, Unicorn, not Djangocon, there we go. So we've been playing with Mindheld, but I am a little bit afraid that nobody uses it, so what is this thing?
What worker class were you using for Geovent?
So I've used Geovent and the sync one. I saw very little difference in my code. Our data models take up a fair amount of the CPU. And so I think that basically we just weren't, like Geovent wasn't helping us very much because we were basically CPU bound on some of our problems, is my guess. I didn't really go all the way down the road of it. Yeah, merging the two systems. So now I can merge kind of this, traditionally you have a query system that is merged through like some database, but now we actually have a queue system that we can merge if we wanted to. So this is kind of like how I see like our architecture these days is I have a large data processing system, and we're not doing as much data processing as I've done in the past, but we'll get there. But then having the query systems actually be used by that as well in training models, and that's kind of our merge of the systems. So hopefully that's gonna be fun. things I've avoided. I try to avoid using too many SaaS services. It seems like that every time I turn around, there's at least 6 more SaaS services out there. So like, I don't know, 3Scale, New Relic, and go on and on and on. Yeah, and I avoid using Django just to get twice good to rant. Some things I'm thinking about moving to the future is Google Cloud, because I don't know, I kind of don't like being locked into AWS all the time. Switching to Lambda or Google Functions, because a data model really is very similar to what Lambda's doing. So if all I need to do is run my Lambda run a model system, then it would seem that Amazon Lambda would be pretty nice for it. And there's also Armada, which claims to be a Docker container system that just handles a lot of this for you. I think there's like Armada and Kong and a whole bunch of systems that do this just for you out of the box. Has anyone used Armada in the room? It's kind of new.
Yeah. I was going to ask, what is this that does for you?
What do you mean?
Does this for you out of the box? What is,
oh, you mean the Amazon Lambdas? Or the API gateway, the scheduling of tasks, the auto scaling, like everything that first slide that I don't do.
Oh, okay.
Actually, I'm actually quite jealous of. There's a startup across the hall from us, and they write everything in PHP, and God bless them. They're all 22 years old and they love it. But the one thing I will say is, has anybody ever used Laravel? Nobody? Okay. Touched it? Sort of. So Laravel has a really nice system, Laravel Forge, which handles a lot of these systems for you. So it's like, fire your data scientist or your DevOps person, and $30 a month will handle all your scaling, all your migrations and everything else for you. But the only time I've ever been jealous of PHP in my life is when I was building all these systems out. Cool. Well, that's my talk. Any questions? Any words of advice? Yes?
Quick question. So you mentioned a database a couple of times being like the limitation for a single point of failure. Have you thought about creating redundancy on a database level?
Oh, sure. I do have redundancy on my database. I don't run. Right now, I'm not having 200 queries per second, so that it can manage it just fine. In the future, I might need to. There are lots of databases are one of those systems that there's a salesman around every corner trying to tell you their database can do a thing, and at this point, I'm just like, well, it basically what I have is working, and I probably will go to Cassandra at some point for a lot of simple queries for my online transaction, for my online analytics. But I can launch several databases in my auto scaling route. So if I do end up going too heavy, I'll launch another database and acquisition it and things like that. So I guess I can talk about auto scaling at all. That's something data scientists, I guess from being a cluster guy, that's something I've thought a lot about. So auto scaling is pretty simple to me. Just fire up another system and point it at different places, right? Any other questions? Yeah.
What's your bottleneck now after all the transformations you've made?
My bottleneck now? So you could always use. So I could always use faster connections. My data model is probably my bottleneck now. I can only run so many cores, and I can basically only run. I don't have the numbers in my head exactly how many I can run, but I think the data model is.
Your gut feeling is that the data model now is.
Yeah. I think there's always more if I could get rid of more connections, and then I would just beat the data model. But the data model is a big thing that I have to speed up. Cool. All right. Thank you very much for your time.